Thank you for coming in such tremendous number, first of all. I hope all of you make it to the end of this session. Well, to give you some background on the topic I'm going to discuss today, at first when advisory board wanted me on a conference, I first thought that I would do this hardcore session about pull-push functional reactive programming. But then I started working on samples in Java, and I felt like, why the hell anyone would do pull-push functional reactive programming with all this toolchain around Java? So I decided I need to destroy something beautiful. And my name is Piotr Limanowski, and I'm here to hurt your feelings and flame you a little bit. So let's first ask the burning question, is Java really dead? Just looking at the room, I would say nope, it's not. It's alive and kicking, but Java, in fact, might be kind of dying, because there's a number of arguments why it might be happening. Actually, all of those come from internet, but the last one is my own personal favorite, and I added it by myself. If you take a look at the most popular projects or growing projects on GitHub, Java projects are primarily Android projects, and there's some projects that are done by enterprises like Netflix. Because there's great talk by Russell Winder about Java is dead. I think it was done on Devox, but my take on it is kind of different. I think that most of us are primarily thinking about their own kind of career plan. And DHH, who's known for his uncompromising language, he said that programming is the thing that he's spending his time on, then it would then better be awesome. And thus, is Java really dead? So I don't know if you guys know that in COBOL community, they have this banking community. They have this paper magazines about COBOL. They are, I think it's like a monthly magazine, and most of the articles are obviously about COBOL, migrating COBOL to other languages. And in 9 out of 10 cases, it's COBOL to Java. And this is weird, right? But why is it weird? It's weird because Java does not change. Java hasn't changed since its conception. And bankers want their code to run in 50 years the same way it's running right now, literally, truly, even if there are no programmers whatsoever. So why not C then? Because C changes depending on architecture you're running it. And Java is source and binary compatible since forever. This leads to horrible bugs. Well, type erasure is one of those. People tend to say that type erasure is a quirk of our language, but it's a horrible bug to have in your code. Because I don't know if anyone here hasn't faced the type erasure, but it hurts you a lot. So let's change that. And there's someone somewhere someday said that to change something, you need to attract those crazy, eager, passionate, and enthusiastic people to do it. And we're all that, obviously. We're here, we're trying to do our best, but why there is no change? Because the thing that we miss is the thing DHH mentioned, it's happiness. Because while coding, most of us think that I'm coding and I'm going to deliver this change and people will be happy and I will be happy. But while coding, I don't feel happiness while coding in Java. Because we're like professional singers for money. And, well, let's not go this path. Let's say we're enterprise singers. That's good enough for me. So let's dissect those things. And I split the scenes in a couple of groups, and most of this comes from this burning feeling that we kind of, as a community, as people who create new things in Java, are kind of sociopaths when it comes to new people coming in and trying our toolchain, which is years old. So first, there's ignorance. We tend to ignore many of things around the language, but above all, we live in this comfortable world of IDE. You can do everything, IDE, just point, click, several minutes later, you get things running. But we tend to ignore one thing that is awesome, Shell. Shell has changed a lot since its very beginning. It's a pretty awesome tool that boosts your productivity just to pick the right choices. And there's a number of things that are there in Shell for us. You can multiplex your terminals, have great editors, and all that. And there are all even sane defaults that you can use and grab from GitHub, clone into your own home directory, and you get awesome setup, someone tailored for years. So I mostly use Shell for test feedback and a REPL. And a REPL is one thing that we really miss in Java. While working in Ruby or Scala even, or any other language that provides you with a REPL, then you tend to go towards something like REPL-driven development. It's another buzzword, but the idea is pretty straightforward. You just try to experiment with your ideas of how you'd do such and such task. And then you know how to write a test. And then if you don't know how to implement it, you then go try it out in test. And yeah, in REPL. And you create it. And you are in sane red-green refactor cycle. There's a great talk about from Konrad Irwin on YouTube, I think, about REPL-driven development. There's more to it, but I highly recommend it. So most of us use Git from command line, because that's the cycle of life of Git user. At first you try to use your IDE, then you try to use any sort of tool that is more powerful than your IDE, and then you said this, and I'm going for Shell. And you do all the stuff in Shell. And while you're there, why not make use of things that were actually made for that? Why not use smart prompt that would tell you which branch you're on and what are the changes? And actually, there's one pretty significant thing in here. The last two come from James Lewis's presentation about microservices or services the Unix way. I think it's the oldest presentation about microservices. James Lewis was working on a project where they figured how to create an extremely large system in extremely short time by creating distributed teams that connected via something like pipe operator. And the whole idea came from Unix back then. So while you're there, you tend to think, yeah, let's do everything in Shell. You start to create your own tools, you try to work it out, and then you figure out you're a Java developer. And Java has very limited capabilities when it comes to Shell programming. It's ugly, basically. There are no great libraries that would help you handle working from command line. But let's take a look how other people do this in other languages, because that's where you get inspiration. So there's this library in Go. I'm not really great fan of Go, but I'm using it for some of the things. And they created this simple library. It looks almost as ugly as Java. But they created this library that has one significant value over Java. It's cross-OS, and it provides you with bash completion. So if you create a tool that is more complex than you expected, then you can just have all the things being completed from bash by pushing tab. There are many other options. Personally, I mostly use Shell and Commander. It's a Ruby gem, well, Ruby library that allows you writing pretty good programs. But I'm kind of in this case, I'm kind of falling for Ruby because I'm using Ruby heavily over in my shell, whatever. There's also an option in Scala, but there's a JVM overhead you have to deal with. So just decide on your own. Another thing that kind of hurts me is that we as Java community are pretty bad at updating Java versions. Every now and then there's a conference talk about there's a new great version of Java coming. Who's on the previous version? 3 people. Because we're real bad at upgrading things. And it's not only coming from our fear of doing this. It also comes from limited capabilities when it comes to great toolchain around updating things. Because in Ruby, they have totally different approach. They, when Mats, the creator of the language, says there's going to be a huge breaking change in another version of Ruby, and they are like, hell no. It's, well, I thought it should have been done like years ago. And over the weekend, everything is ported to the new version. And it's because they actually have the tool to do so. There's a Ruby version manager that allows you quickly change versions depending on directory. You can set it globally and all that. And then you simply run your tests, try out your app and all that. But in Java, you have to download it, apply for license, log in, or whatever. But there's a thing that's hope. I don't think it's strictly legal, though. It's like Java port of RVM. It provides you the same commands, but for Java. So it's doing all the things like passing headers to Oracle that, yeah, I apply for your license, thank you. But it's pretty cool. You can test out Java 9 in your directory X. That's cool. Another thing that we kind of are guilty of is ignorance of distribution before thinking about creating applications. Because to me, there are only 3 good ways of deploying applications: native OS packages, self-contained fudgers with run scripts, and containers. Obviously, there are no application servers because application servers are dead. Application servers are a legacy software that was meant to run many applications in a single OS process because we had like memory limitations, processor limitations, and that is pretty much where app servers fit in. And in 21st century, does anyone have in here issue with memory or processor? You just click it out and you get more RAM on Amazon. And the thing that really hurts is that they put accidental complexity into your app. Because how do you say that your application, this version of your application depends on such and such version of your server? You can't, because well, you could use SaltStack or Ansible to do so, but it's not part of your application, right? And you have to monitor them. They have like number of metrics, most of them totally irrelevant to you because they talk about how the server itself is running, and it has 100% uptime, whereas your app has like 80 or 99, whatever. And you have to monitor it either way. And on top of that, they do not provide you the features that are actually coming from stability patterns, like calling home, deadman switch, or status pages. Those are the things that are pretty much extremely important when you want to have your app stable and running for a longer period of time and have it fully monitored. As we're at monitoring, we tend to think only about development and not about operations. Because in Java world, in many companies, there's this split. There's a team who's doing operations, and there's the team who's doing development. And they have like SharePoint on top of that, or even have a common tool. or they just sit in the same room. But the thing is, they're not thinking about creating the app together. And this is why we have Snowflake development environments. Because with Snowflake development environments, every environment is a tiny bit different. And when you want to kind of deploy the application, you're not really sure if it's running in the same environment. And oftentimes we work in IDEs and run and test our applications on our own host machines. And yeah, it often causes issues. So that's another thing. But yesterday there was a great talk by David Gann. He mentioned the continuous delivery book. And I would add another book, which is Realistic. It's Michael Nygaard's book. I think it's one of the best IT books I've ever read. Michael Nygaard, in 2007, almost 10 years ago, he wrote about bulkheading and circuit breakers, things that are totally needed while building things like microservices. So we tend to build things like that without using those stability patterns. And stability patterns Michael Nygaard provided. Well, the thing is, Michael Nygaard was then turned operations guy, and now he's DevOps chief whatever. But the thing is that Michael provided all those things that are now common knowledge among many communities, and they are growing in microservices community. So whether you're building a monolithic app or microservices, try to think in terms of stability always. And the book is, I will show it once again. The book is Realistic, and you should definitely read it. Well, there's this library made by Netflix Enterprise that implements some of the patterns. They even give you a dashboard on top of that. But that's just the starting point. So that's my follow-up to yesterday's presentation. And another thing, we tend to talk a lot about logging. And a couple of years back, I went to Dan North's presentation about, well, it was training. I think it was accelerated agile training. And there was a group of people in the room, and Dan said that he's pretty much logging to console in Ruby, he's using puts to just write to console and go away. And they went like, what are you doing, man? There are logging frameworks. You use logging frameworks to do things. And after a couple of minutes, they started discussing logging frameworks internally. And they've been discussing whether to use log4j2, and if you should, if no debug setting, then something. And, well, it's totally irrelevant. You have to be aware that adding any library to your code, any external library, is pretty much sacrificing your knowledge. And we are sure of that. But one thing that I think it's really valuable in here is that having logs that are have really specific configuration, really specific build is extremely important. Whether you're using Logly or Papertrail, those are all great, or even Elk. Those are all great tools. But the thing is that from time to time you want to grab something. And if you have like 10 different types of logs or 10 different lines of log per something, it's undoable. So this is the format I've been using for a couple of years, and it's pretty great. It feels good enough. And then there's this great talk by Rich Hickey, the creator of Clojure. Rich made presentation simple, made easy. And the thing is that we do the other way. Easy is our default choice of doing stuff. We learn from the past without any conclusions. So let's talk about something that sucks, build tools. Any build tool in Java sucks, pretty much. Because there's Maven, which is default choice. And in Maven, it is pretty straightforward. It's hidden in your IDE. The IDE generates XML that has a single root node project. And a couple of weeks later, you get 1,500 lines of XML. I mean, 1,500 lines of XML? Yep, and it's apparent. Because there's a separation in Maven, right? You can create a parent, and then you have children, and it's separation. Yeah. So then there's Gradle, and Gradle looks awesome because you add a single line of Gradle, and then you get all the files in your all those Gradle files in your working directory, and Gradle tends to grow significantly over time because people tend to grab code from Stack Overflow, put it in because no one really understands Gradle. And I think it's almost great success. Yeah, but whatever. When James Lewis did presentation on services the Unix way, he was asked what kind of build tool in Java he's using, and he said Ant. Ooh. And the thing is that Ant is a pretty decent tool, but the thing is, it's as James Duncan Davidson, the creator of Ant, said that, yeah, it's XML, man. I wouldn't do that again. So how the thing is done in other communities. Ruby has Rake, which is, I think, one of the greatest build tools around. And the really significant thing here is that Rake was built several years after Ruby got popular. And they created this crazy project. Let's do Make in Ruby. Why we are using Make? Let's do this stuff in Ruby instead. Because Make has its own DSL, its own syntax and all that. Let's do this stuff in Ruby. And several years later, Rails, the most important web framework for Ruby that actually made Ruby popular, has 67 lines of code in there. And it does different things like publishing documentation, building the application, smoke testing, and all that. Because Rake has pretty straightforward DSL. It wraps your functions into DSL based on pretty much Make. So you create a task and it does something, and you can watch directories, files, and it works. But there's another concept that came up a few years later. It's heavily promoted by Dave Thomas of Pragmatic Dave. He said that Elixir is the thing he really fell for. And yeah, Elixir is great. And they came up with this idea that a language should come with, well, build tool. So they created Mix, and it's available. You download the language, and you get a build tool and all the toolchain around the language. And Mix has this approach that you could create a project with Mix. You can set dependencies in Mix, and it doesn't interfere with your front-end web stack. So that's one thing that I really feel hurts us, front-end stacks around Java applications. Later on, if we have some time left, I will show you an Elixir application. So another thing that really hurts, especially people that come into Java world, is that dependency management is, well, this. And the thing is that in many of the communities around, they have several ideas around how you could structure your dependencies. So you either have global or local dependencies. And you have configuration per directory, and we don't have that. You can try to override settings XML and all that stuff, but in the end, it doesn't work like this. And I have a friend of mine, actually, he's a Rubyist and wanted to try Scala. And Scala builds on top of Ivy, Maven, and several other concepts in Java world. So he pretty much failed at this, because SBT looked pretty great at first, because it started as a simple build tool, and now it's Scala build tool, obviously. Because yeah, aside from being type safe, it's a project in your project. So SBT is creates a project in your project. But the thing is that those are inherently the same issues, because there's totally different way of thinking in different communities, and we tend to think globally, because Java is global, right? And yeah, so in Ruby they have bundler, and that's also pretty important to say that it's not built when Ruby was made. Bundler was another crazy project by someone somewhere who was fed up with downloading stuff with scripts and all that. So they created an extremely simple DSL. You just add a single line with a gem token, and then the name of the gem. And the pretty cool thing is that you can, do you remember Ivy, version management? In Ivy, you could use this weird syntax for upgrading dependency. You can even, I think, you can also add some of the tokens in Maven, like plus, so it would upgrade on the third on patch level. But they have these, well, operators that if you're really at the level that you need to upgrade something automatically, it would use the version that you predefined. And obviously, you can't see versions here, because the idea behind Bundler is to manage those versions externally to your code. So you could either define a version 1.0 or version newer than 1.0 but not older than, and it would create a gem file log with the versions you're currently using in your application. And you could grab projects from GitHub. I think GOM, I think GOM is the name of the currently most popular Go dependency manager. And they have, well, pretty similar idea that you should grab projects from GitHub. Yeah, and the thing is that Elixir does thing a little bit different, because they are using Mix also for dependency management. And it's like the Omway way, all in one. But I'm not quite sure if that's the thing you should do, because maybe with some one in your team trying to be type safe all the way, you end up with SBT. But well, it's pretty similar to what Bundler and Rake tried to create. So you wrap things that look pretty similar to what you have in Bundler into a method, a function, whatever. So right now we have all the stack covered, all the issues around the stack, but there's one big, huge thing that we are left. I mean, web frameworks. Let's talk about web frameworks. Or maybe let's not talk about, well, Java web frameworks, because Java web frameworks used to fight HTTP, and that's why there's no JSP, JSF left and in any new project, because they thought that they could fight HTTP architecture. It's like SOAP. You have like get and whatever. And there was a great discussion between Josh Long, who was doing a talk in here, with Reza Rahman from Oracle about JSF, whether to use JSF or use anything else. And actually, I think it was deleted from Twitter, but you can also find it on the web archive, and I highly recommend it. Because we could talk about Spring, but let's not talk about Spring. there's a new notion in Java development. You actually build frameworks from libraries, and that's awesome because you add some glue and it works. And in most cases, it's enough. But well, you're not writing a startup anyways, right? Because yeah, why we are not writing startups in Java? So I would like to show you one thing that's pretty significant, and I've been using Phoenix and Elixir since I think this year's PolyConf. They released version 1.0 sometime earlier this year, and yeah, in Phoenix they are using the mix tool. Phoenix is like Rails for Elixir, and Elixir is the language that is built on top of Erlang VM. And it has syntax pretty similar to Ruby, and it's actor based, obviously. And if you build an API with Elixir, in most cases you have like nanoseconds to get a reply from the server. So maybe if we manage to have some time in the end, I will show you the application. And one thing that I'm actually left in here is that we often create default thought presets in our minds. And one of them is what Ralph Johnson was discussing yesterday. I mean, design patterns. And it's awesome to know design patterns. But it's totally essential to understand them. Because I've been doing lots of recruiting this year, and there were some pretty significant ideas of lambdas coming to Java. And well, design patterns are like coming from the code smells, from the languages. And some of the issues are being resolved by using pretty much new constructs in the language. And while discussing design patterns, I always try to ask people whether they really understand them, and if you could use anything else than design patterns, like functions. And yeah, people tend to fail at this, because, well, we use design patterns for so long, and we take them for granted that we don't try to question them. And this is what I've been thinking, how to leave you, what thoughts to give you for the end. I would tell you that you should update your tools and look beyond the fence, not only the Java world fence, because there's lots of concepts in JVM-based languages that are inherited from Java. So let's, from time to time, take a look at things that are done in other communities, and try to question everything that you get from your teammates, from your older colleagues, whatever, and kill the old stuff that's irrelevant to you, because Java really fails at this, and it will blow in our face. Having vectors in JDK will blow in our face, and having backwards compatibility since forever will blow in our face. And on top of that, I think the most important thing is just to have fun. Have fun writing, not only delivering changes. And there's one last thing that I would like to leave in here. In the Ruby community, they have this acronym MINAS1. Much is nice, and so we are nice. And this leads to pretty great things happening in Ruby community, because they welcome diversity. They welcome people with different approaches to stuff. And when you go to a Ruby conference, oftentimes there are people that are responsible for grabbing those new people into the crowd. They often end up at speakers' table discussing totally complex stuff. So this is from me. Yeah. Does anyone want to look at the Phoenix Elixir app, or you want questions? So shall we do questions, or you want to take a look at the code? Yeah, that's quite resolution. That's Emacs, by the way. Notice the little nyan cut in the bottom. It really, I was trolling a friend of mine, and he actually is building our applications oftentimes, and he adds lots of stuff in there, lots of useless stuff. So we pretty much added nyan cut to our build, so it's playing on the speakers. Okay, so as I mentioned, Elixir is pretty much actor-based language. So in here, it's like the top actor that you create, and it has its children. And here we create actor who is supervising the whole processing. It's endpoint, so it's the actor that is supervising everything that comes into our application. And then there's the worker who's doing the stuff from the getting from the repository. So let's try to run the application. Yep. Oh, it's so hard. Yeah. Yeah. Awesome. And that's an Elixir app. Right now, all the async frameworks tend to create the chat applications. So this is one that does all that. So ping, and you can create messages. So you create this actor hierarchy, and that's, I think, the pretty cool thing in Phoenix is that it's actually reloading if you change the code. So that's the thing that's useful for that. And then the endpoint. So there's lots of comments in here, but obviously here's how you create context. Then we do some parsing of JSONs and create sessions, and then we plug in router, which is pretty much doing all the routing for messages. And that's the whole code. Yeah. So I think we have like 2 minutes for questions. Yeah.
Okay, so you mentioned that Gradle is bad, Ant is decent, and then you showed Rake or the next tool even, and both of them are doing basically the same thing as Gradle. So maybe it's not about the tool, but about the people using it with only Control-C, Control-V.
Yeah, that's part of the thing, but inherently Gradle has way too many pulls and levers to be pretty straightforward for people to jump in and do stuff. That's the same issue that is in SBT, right?
Jakieś pytania?
Okay, so if you should have any questions, I will be available throughout the day, so just grab me.
Dziękuję bardzo.
Thank you.